Hi, today I am here with George. George is a lecturer at the University of Canterbury for Mechanical Engineering and Design. Hi, George, welcome. Can you please give us a little bit more background about you and how you got to your position?
My name's George, and I work as a lecturer at the University of Canterbury down in Christchurch. I'm focusing on mechanical system design. How did I get to this position? Maybe like you, if you're a high school student watching this, I was once at high school, and the subjects that I kind of focused on were quite maths and science heavy, so doing calculus and physics. But I did also have kind of passion projects that I was able to do when I was working with hard materials technology. And so there's a real application, I suppose, of all of those three subjects in what I now do as a full-time job. So following my time at high school, I went down and studied a Bachelor of Engineering and focused on mechanical engineering as my kind of discipline of choice. I obviously loved it so much that I stuck around even more. I didn't leave university and get straight into the workforce. And I spent the next 3.5 years doing a PhD where I was focusing on kind of applying engineering skills and analysis to basically understand the arm strength of people who have had a spinal cord injury. And so the whole reason for that project was looking at if you're a designer or someone that wants to make something for someone who does have some reduction in function, both in their kind of limb strength, but also their kind of dexterity, what kind of data you would need to help you do that in a really streamlined way so that you don't spend a bunch of time developing something that's never going to work because you didn't really know that it wouldn't work based on the numbers you were given. And so, following my PhD, I kind of started with a few kind of fixed term jobs where I was not necessarily guaranteed to be a kind of full-time lecturer, but now I am at the start of this year have been a kind of full-time lecturer. So that means that my job is kind of half lecturing and teaching and engaging with new students coming through who are becoming mechanical engineers. And then the other side is doing research, kind of similar to what I was doing with my PhD, but also helping other students to complete research in quite a range of different interesting topics. But yeah, that's
That's
the short one.
awesome. And how did you come up with your PhD subject? Is that like a personal thing for you? Is there someone that you knew you needed to help, or it just
Yeah, so I suppose when I got into engineering, um, I did really like understanding how things work, but I did also want to make the world a better place in whatever way I could. And so it wasn't a PhD topic that I kind of came up with myself. I saw that my supervisor had kind of done a bunch of work in that area, and it was just extending kind of previous work that had been done um, and building on that. So that's often what can happen um, with people who are doing kind of postgraduate study is that there might be a really big project and lots of people either kind of passing the baton because typically your PhD will take kind of 3 to 5 years. And then you can sort of actually have a job where you are a researcher full time. But yeah,
okay, that's really interesting. And what sort of projects are your students coming up with at the moment? Just out
cool.
of
So
interest.
yeah. So like a kind of classic Kiwi, I suppose, sports are something that I find particularly interesting. And so we have a lot of interesting projects in that area. So some of our work, we have a PhD student that's looking at soft shell headgear design for rugby and the idea of if you can kind of better attenuate or absorb the energy or basically make head impacts in rugby safer, that will be kind of beneficial for the people that are playing the game. And then we've also got a few groups of students that are looking at a range of new devices to be used in field hockey or also analyzing, what makes a good hockey stick and how could you possibly improve the design for the specific technical, well, the specific kind of styles of play, I suppose. So I don't know, this is sort of going a little bit deep. If you don't know hockey, then it might not make that much sense. But there is one side of it where you obviously want all of the energy from your stick to go to the ball so that you can kind of make sure that You don't have to swing as hard, or you can actually get the most out of an impact. But then there's also what would make a good stick for the skill of drag flicking. And that's something that we've found that not many people have done too much research on. So we're sort
Yeah.
of in the early stages of that. And then basically by doing this sort of initial analysis, we're able to see if there's an opportunity to make those kind of things possibly better by having some sort of innovative design.
Wow. Okay. So without sounding super ignorant here, and bearing in mind all these amazing projects that you've just talked about, like what is mechanical engineering? Like what sort of jobs can kids go into as a mechanical engineer? Because that what you've just described to me, I guess it does fall into it, but I hadn't really thought about that side of it.
Yeah, it's a really hard thing to grasp because I think when people hear mechanical engineer, they think of cars.
Yeah.
Um, but the way that I would describe it is that mechanical engineers um, are involved with anything that moves. So they're involved with any kind of object that has motion or change. Sometimes that motion can be good and you want to enhance it. And then sometimes, like earthquakes, that motion might be bad and you might want to actually reduce it. And so, really simply put in a crude way, that could be one way that you kind of differentiate mechanical engineering to other areas. And then from there, as you've said, well, it's not necessarily what you think because it can be quite broad, right? So,
Mm.
in our department, there are people that are working on things like aerospace problems, designing rockets. We do have the classic student Formula SAE car competition where students design and build a car every year. But it goes further than that and even looks at the human kind of elements as well. So some of the other projects that our students are involved with are human powered vehicles. So they're trying to currently make the land speed record for a human powered vehicle. So at this stage, they've got a trike, I guess you would call it, since it has three wheels, but something that's fully fared. And then we also have our kind of biomed side of things where students are working on things like prosthetic limbs or kind of artificial hearts. And so it can be any
Amazing.
motion.
It's
So
so varied.
so for all of those things though, for example, there is an application of how the fluid flows over them. So for a car, it's pretty easily to think about the drag, but if you're making an artificial heart, then you kind of want to make sure you're understanding how the pump that's in that system is working and how the fluid, which is your blood in this case, would be flowing. Similarly, if you're making a high-speed vehicle, you're looking at controlling the drag and understanding those kind of boundary layers. But generally put, the subject areas that you'll cover as a mechanical engineer are sort of all tied together with this engineering design kind of process that you'll use. You'll have an understanding of material science, so deciding what materials are appropriate, how you manufacture them, and what their kind of limitations are. You also look at fluid dynamics, heat transfer, so how things heat up and cool down, and then dynamics and vibrations are kind of the main subject areas that you'll look at. And so dynamics and vibrations can be quite a complicated one, I suppose, but it's not necessarily just physical, like an earthquake, dynamics and vibrations, but it could also be things like acoustics. So there is a bunch of research that's been done in our department looking at cochlear implants and how you can make them smaller so that they're kind of a more invisible product for the people that use those. So yeah, it is very broad.
Wow. It really is. So, bearing all those things in mind, what sort of subjects should students be taking at high school if they want to go into being a mechanical engineer?
Yeah, so any engineering will require that you do have a solid understanding of maths and physics. So you will be able to look up on any of the kind of university websites as what are the subjects that are critical, and normally they'll say that you need a certain number of credits in calculus and in physics. And then depending on the discipline, you may also need to have done chemistry to kind of year 13 or at least year 12. But again, you'd have to look at those kind of regulations for the specific place that you want to go.
Yeah.
One of the things I would almost encourage in terms of what makes a really good mechanical engineer is having a practical mindset. So either if you've got a hobby, doesn't really matter what the hobby is, but some sort of passion project that you're able to work on where you are sort of tinkering or pulling things apart. For me, when I was going through, there was sort of two things in that area. So I did wood technology as my kind of one of my subjects. And so in that, you pretty much were following the engineering process, coming up with concepts, evaluating how you'd put them together, and actually making a piece of furniture at the end of the year. And so I'm sure that there are similar kind of subjects where people might do hard materials or soft
Mm.
materials technology, where you are doing that portfolio of work. Sometimes it can be hard to fit in that kind of subject, depending on what your school actually lets you do. So you could also have something sort of outside of school that you work on. And so for me, I was lucky enough that my first car was a 1980 Mini Leyland. So basically your classic small Mini. And the the thing with old cars is they often break. And so I had to kind of learn, this part has broken. I need to pull it off of the parts engine and put it onto the engine that we're using at the moment. And so I was able to get a hands-on experience with how those things kind of work, and that it's not essential, but it definitely helps for particular areas of mechanical engineering if you are going to be engaging with people that are making things. So
Mm. Yeah.
it's sort of a tricky one where, as I've described, mechanical engineering gives you this really broadly applicable skill set. And some people might spend their whole career kind of really focusing on and analyzing and simulating complex kind of problems on the computer. But a lot of people will also be working with companies that are manufacturing things or fixing things, and to have some sort of understanding of how those parts interact with each other. And often by having that physical experience with it, it gives you a more well-rounded approach to be able
Mm.
to provide a solution that's actually going to be useful. Because otherwise, you may get experienced fabricators that say your drawing, the thing that you've designed is great on the computer, but there's no way to put it together because how would we hold it, or how would we
Yeah.
get the welding tip in there, or all of those kind of considerations is something that you learn best by actually having some sort of experience kind of making things yourself.
Yeah. And in your position as a lecturer, are you seeing many girls coming through engineering?
Yep, I'm not sure of the exact numbers, but it's definitely I think it's increasing, which is quite good to see. I don't think there's any reason that gender has anything to do with what makes a great engineer. And personally, what I've seen through the courses I've taught is some of the best performing students in my class have been the females in the class. And so, yeah, I think part of that, well, I'm not sure. I'm
Yeah.
not sure what is, yeah, I think it's going away from being that perceived old boys club, and hopefully things continue to kind of get lots of women in STEM.
Mm.
Because yeah, a lot of my, as I was going through, a lot of my friends were girls, and they were and are great engineers today. So yeah,
Yeah. I think it's women have a really good attention to detail. I reckon that helps,
yeah,
especially with
yeah.
engineering, I reckon.
And I think,
Um,
well, I think one of the things as well is what I've heard is a lot of um, a lot of high school students that are doing physics and sciences will often be weighing up whether to do kind of a health science
mm,
pathway if they're wanting to help people. And I think one thing to note is that like you can make a really big difference if your goal in life is to have a really big positive impact on other people's lives. As an engineer, you're probably able to have a greater impact than um, a doctor who's a surgeon, because there's only a finite number of surgeries a doctor can do. But if you're an engineer, you might be actually the person designing the things that those doctors use, or whatever healthcare equipment that could have a huge impact on, thousands, if not millions of people, depending on the size and the scale of that. And so that would be something that is is worth noting. But
yeah, that's
yeah,
a great plug for engineering right there.
yeah. Well, I guess it is. It's what depends on what what interests you and what jobs you can kind of do in that interest. So there might be, yeah, there's no reason that there can't be great, yeah, females in any kind of engineering and on any of the projects that I've discussed. So
Awesome. Well, we'll finish off the interview with what would your pieces of advice be for any high school students that were wanting to go into university to study engineering?
any pieces of advice?
Yeah. Any gems?
Um, oh, I've not thought of this before, but I guess I would say, yeah, keep an open mind and um, apply yourself. I think engineering um, is a challenging kind of subject. Well, there's lots of because there's so many different things. It's not that it's going to be everything's a walk in the park, but that's kind of part of the process. And when things are hard, then that means you're probably going to get the most out of it. And so keep trying, and yeah, basically with a bit of stickability, I'm sure that kind of anyone can get there. But yeah,
Cool.
don't
Okay,
give up,
well,
I guess is
don't give
is
up.
the answer.
Keep going.
Yeah.
There's lots of things that I've been hearing from other people is, you do a lot of work working in groups with other people, so that communication and listening and talking to people is really important, and being able to collaborate and share your ideas amongst other engineers, because it seems to me that, you don't generally work by yourself. You're normally working in a group with other experienced people. So those sort of key skills are quite helpful to have. That's what I'm hearing. But the resilience one and sticking to it is a good one too.
Yeah. But like I guess you can also apply the resilience to the group thing. So if you do end up going to university, you'll inevitably be put in a group project. And if those are randomly selected, it's probably that it's probably going to be the case that you get a mix of people and a mix of personalities, and
Yeah.
it's uncommon that every group project will work seamlessly. And
Mm,
I think at the time students find they're really frustrating, and like fair enough, but you you do get a lot out of those
mm,
experiences when there was some friction or challenges or people that weren't kind of performing how you'd want, and then how you overcome those challenges to actually still get um, the assignment kind of
mm.
done are kind of quite valuable. So
Yeah, it's group
yeah,
work can be quite hard, in high school as well, and yeah, and as adults. Yeah, definitely. It's and coming across people that you don't necessarily connect with or understand or can work with, but you have to find ways to do it because that's your job. So it's definitely something that kids need to be aware of, like when they move out into the real world, into real jobs.
yeah,
Okay, well, thanks, George, for your time. I really appreciate it. There's some really valuable content in there that I think would be really good for kids to hear. So thanks for that. Appreciate it.
awesome. Thanks, Claire.